Hello, everybody. Today we are going to be discussing probably the most important topic in chemistry, and that is the concept of moles. So, when we talk about moles, what we're going to do is talk about what are they, and we're also going to talk about why they matter. So, we need to, write out what a mole is. So, 1 mole is defined as 6.022 times 10 to the 23rd atoms, right? So it can be either atoms, molecules, or particles, it doesn't matter. A mole is just a fixed quantity, right? So when you have a mole of something, that means you have 6.022 times 10 to the 23rd of that, right? So why is this an important concept? Well, let's just really quickly take it into account. Let's say we have lithium. So lithium is the third atom on the periodic table, or the third element on the periodic table. And let's also say we have fluorine. Fluorine is the ninth element on the periodic table, right? So fluorine, if we're looking at just the nucleus, right? The nucleus of fluorine should technically, or not technically, is bigger than the nucleus of lithium, right? So now let's say if we have 1 gram of each of them, 1 gram of fluorine, 1 gram of lithium, 1 gram of fluorine. Well, technically, there should for 1 gram of lithium, there should be more lithium atoms in that gram than there are fluorines in the 1 gram of fluorine, right? And actually, if you look at the number of moles, that's true. So to get the number of moles, you just divide by the molar mass, right? So we'll divide this by 6.9 grams per mole, and this actually gives you 0.14 moles. And for lithium, the molar mass is 19 grams per mole, and this actually gives you 0.05 moles. So you can see immediately, because fluorine has a larger nucleus, you actually have a smaller number of moles. So this is like kind of saying, if you have a pound of bricks and a pound of feathers, which one's heavier? Well, they're the same weight, but the quantities differ, right? So in this case, it's saying, you have a gram of fluorine and a gram of lithium, but because lithium has a smaller nucleus, or a nucleus that weighs less, you have more lithium atoms in that gram. And this is why moles are important. So, give me 1 second. So, moles give you a 1-to-1 working ratio, right? So if we just consider, hold on, let me move this up. So if we just consider the case we were just talking about, what we had was 0.14 moles of lithium. And if let's say we just react it with the 0.05 moles of fluorine, the only amount of lithium fluoride you can get out of that would be 0.0 moles of lithium fluoride, because you would be limited by the amount of fluorine in that reaction, because there's much less fluorine than there is lithium. However, if you were to just say, I'm going to react 1 gram of lithium and 1 gram of fluorine, and that'll produce 1 gram of lithium fluoride, that's incorrect, because there weren't equal number of atoms of lithium and there was 2 fluorine in those two quantities. So that's actually why moles are important. So now we'll talk about how moles are actually calculated. So let's just take a simple example of copper sulfate. So CuSO4, right? So copper sulfate has a molar mass of 159.6, I believe, grams per mole, right? So now let's say you had 10 grams of copper sulfate and you wanted to know how many moles of copper sulfate there were. Well, based off the molar mass, you know that for every 159.6 grams, you have 1 mole. So here, grams of copper sulfate will cancel on both sides, and you'll just be left with moles. So this number is going to be, 10 divided by 6. This number is going to come out to be 0.063 moles of copper sulfate. So that's actually how moles are calculated. And this formula, or this unit analysis, actually lets us derive a formula for moles. That's very simple, and it's just, I'll go to the next slide. Just N is equal to M over M dot. So this is the number of moles. This is the molar mass. And this is the mass of what you have. So from our previous example, all you would need to do to calculate the number of moles of copper sulfate are you had 10 grams, so this would be the M in this case, the mass of what you have, and you had a molar mass of 159.6 grams per mole. So that would be the molar mass. So just by dividing those two quantities would actually end up giving you the number of moles, and it's that simple. So thanks for watching, and stay tuned for future videos.